So I will have a little bit more broader perspective on the benefits and the added value of CARA and also the European regional reanalysis SERA compared to ERA 5. So just jump straight at some elements of the configuration of ERA 5 and the regional reanalysis, which gives us some clues and hints on the added value. First of all, I would say that ERA 5 has an advantage in terms of a global coverage, of course, and a longer time period covered. ERA 5 also has a more advanced assimilation scheme and provide hourly analysis output. While the regional reanalysis, of course, are regional, cover these regions that we have already seen and a shorter time period, and also only provide 3 hourly analysis output, but they provide forecasts for every hour. And I should also emphasize that the quality of the regional reanalysis depends heavily on ERA 5, because ERA 5 is used as lateral boundary conditions and also as for large-scale mixing within the regional models, meaning that the large-scale weather patterns are kept more or less similar in all reanalyses. However, the main advantages of the regional systems is that they have a much higher horizontal resolution or grid spacing, 2.5 kilometer grid spacing in CARA, 5.5 in SERA, compared to 31 kilometer in ERA 5, which means that the regional systems can provide much more spatial details. There has also been a lot of efforts in collecting the local observations in SERA and CARA, which also Jason mentioned, and these are used and has not been available for the production of ERA 5. And of course, when we have a regional focus, a regional domain, it's possible to kind of focus on those processes that are most important for those regions. So, as also Jason mentioned, in CARA, it's a particular focus on the representation of the cold surfaces. So this is the only picture from Greenland from my side, but this is how it looks in practice. This is CARA, 2-meter air temperature to the left, and ERA 5. And for the large scales, they are quite similar. But they really differ in the small scale details, as also Jason showed. So this is where we see that the resolution and the grid spacing of CARA provide much more details in the more spatial details in the complex terrain of the coastal areas and topography of Greenland. So taking this a little bit further, this is the mean absolute difference between CARA and ERA 5 for a couple of winter months in 2018 from the CARA East domain covering Norway, Barents Sea, Svalbard, and so on. And we see that the main differences are seen over Svalbard and the Norwegian coastline, Norwegian mountains, where we have complex topography not resolved properly in ERA 5, of course. Over the more flat and homogeneous ocean, the differences are smaller, and so is also the differences over the more homogeneous and flat terrain in parts of northern Sweden and Finland. What you see up in the left corner, you see the sea ice. So there is some really big differences between CARA and ERA 5 up there. And that is because CARA actually has a slightly more advanced sea ice scheme than ERA 5, I think, including a snow layer on top of the sea ice, which makes it colder and kind of reduce a quite well-known bias in many reanalyses over the sea ice. Yeah. So if we go on and compare with the observations, we have some time series from CARA to the left for mean sea level pressure, for temperature, 2 meter and 10 meter wind speed. and this is the root mean square error. And we see that the error is smaller for all these parameters in Kara than in ERA 5. So there are some added value here, and maybe in particular for temperature, but also for wind speed and pressure. And a similar story can be seen for Serra. This in the table here, where we have a reduction of the RMSE compared to observations at Swedish coastal stations. And this general improvement and better agreement with observations is also reflected in the representation of extremes. And this is from Serra, the storm Gudrun in Sweden, 2005, and one of the most severe storms there. And to the left here, you see the wind speed at the culmination of the event in ERA 5 and in Serra. And you kind of see that there are some clear differences between the data sets, and maybe in particular over land, but there are also some clear differences in the spatial details over the ocean. And if we now compare with observations for some points here, we see that Serra, the green line, is following the observations in red in a better way than ERA 5 is able to do. So it adds value for this case. And this is a similar example from Kara for different types of extremes, but just focus on the cold extremes during winter to the left here. And the different colors are different regions with different characteristics, and the box plots span the difference in the 5 percentile of the temperature during wintertime between observation and the reanalysis. So ideally, we want these box plots to collapse on the vertical zero line, meaning that the 5 percentile is similar in the observations and in the reanalysis. Of course, they are not. But we see that when you in ERA 5 has a cold bias for in the mountains and along the Norwegian coast, and a warm bias inland, these biases are heavily reduced in Kara dataset. And a similar story can also be found for the warm extremes during summer and for the wind extremes. And as already mentioned, the climate change signal or trends are important in reanalysis. This is from a study by Isaksen et al. This year, where they studied the warming patterns in the Barents Sea and the Svalbard region. And they found that both ERA 5 and Kara corresponds well with the observed trends in the region, but Kara has a slightly stronger trends and slightly more spatial details, and are in general slightly better agreement with the observations. So also an added value for this particular region. Okay, some examples of added value there. Of course, there are some weaknesses and factors limiting the use of the regional reanalysis. And as I already have said, the regional coverage, shorter time periods, and 3-hourly analysis instead of hourly analysis might be an obstacle for some users. And I think that ERA 5 is so well known, it's easy to use. It's used by everyone. It's really scrutinized in terms of strengths and weaknesses, so it's a very easy to go to data set. So it's a kind of a threshold to use something else, I think. And compared to this, Kara and Serra, you need to handle a larger amount of data due to the resolution. It's more time-consuming to download from the CDS, as Jason also mentioned, and it's potentially also more complex to use because of the projection and the grid and so on. So there are some thresholds to getting into use it. And of course, the added value of Cara and Serra compared to ERA5, it varies with parameter, with region, with time aggregation, with spatial scales, etc. And this needs to be explored more. And it's maybe a little bit difficult for users to navigate and see what is the added value for them by using the regional systems instead of the global systems. And of course, all reanalysis and forecast system have deficiencies, and Cara and Serra are no exceptions to that. They are not point observations, and they're not capturing all scales, etc. So should be used with some consideration, I think. Okay, so at the end, I will just mention that Cara 2 is coming. Instead of the 2 regional domains or the 2 small domains, it will be pan-Arctic with a resolution of at least 3 kilometer grid spacing with a period from 1991 and onwards. If we are able to do this efficiently on the HPC resources, we can go down to 2.5 kilometer grid spacing, and even earlier from 1993. There will also be some improvements in the system configuration, and it was a kickoff meeting this week for the project. And the first batch of data are planned to be released in the first half of 2025, and the full data set in 2026. Yeah, so just to summarize, the regional and global reanalyses are representing the large-scale atmospheric features in a quite similar way, I would say. But the regional reanalysis, they really benefit from the finer horizontal resolution, more local observations, and also the possibility to focus on the relevant processes in that region. And they therefore provide much more details if you as a user are interested in that, in spatial details, for example, and better represent the extremes and so on. But of course, they only cover a limited part of the globe and a period of time. And it really needs to be explored more to understand even better the strengths and weaknesses. So, thank you.
So, who wants to ask a quick question? There's 2. We'll actually take 2. Let's start over there. If you make it very short, we have time for 2.
Yeah, I try to. Thank you. Thank you for a nice presentation. So I'm wondering if these benefits from the regional reanalysis can be somehow implemented also in the global reanalysis, for example, ERA6 or something like that. So.
Brilliant.
Yeah, I don't know if that's, I should answer that, but of course, if you can afford higher resolution globally, it's in an ideal world you would do that. But and I think that's what you're aiming for, at always improving the resolution. But yeah, it's demanding.
Thank you. Very interesting presentation. Most of the results are on the added value are focused on the northern part of the domain. I'm talking about Serra specifically. And you said that more exploration needs to be done to compare, and that the added value can change among regions. Could you give us any hint of what you may have explored up to date on the southern part of the Serra domain? And there's that much added value, or there are?
Yeah, I don't think it's necessarily about south or northern part, but it's more about the complexity of the surface forcing. So I can imagine that describing the Alps, for example, is better done in Serra than in ERA5. But yeah, I can't give you any exact answers. Yeah.
Okay, thank you.
Brilliant. Thank you so much.